Hello everyone. My name is Virag Sharma and I am working with programmers.io for more than 4 years. And today we are here to discuss on about array and data structure in IBM. So without wasting any time, let's start the session. So the agenda for today's is we are going to discuss about array, then the types of array, then the built-in function and opcode which are used in array. Further, we will go with data structure part. Then we will see the types of data structure we have. Then we will have a Q&A for the session. So let's start. So array is collection of element of same data type, means you can create an array based on the character values, or you can create an array based on the numeric value. So if you see an example, I have just created an array of 10 character having the size 7. If you see, I have just initialized the value for index 1, I'm having Jan. For index 2, I'm having Feb. And the index 3, I will be having March, and so on. So if you notice one thing, for index 1, for index 2, I have begin with index 1, 2, and 3. So in IBM, so index array index begins with 1 instead of 0. So you need to remember this point. So whenever you are working with the IBM, so you need to start the array index with 1 instead of 0. So then what is the use of array? We will see the use of array to store multiple values in a single variable so that you don't need to create multiple variables for every values. If you see, I have just created one variable array1, which is of character 10, and I can use multiple values to it. Just I need to with the index value so that it will just make it easier to manage and manipulate the data. So let's see the types of array we have. So we have three types of array. First one is compile time array. Second one is pre-runtime array. And the third one is runtime array. The compile time array, the values of the array will be loaded before the execution of the program. So that means at the compile time, the value will be loaded. And in pre-runtime, we will be using array file so that for the values, so that whenever we want to use the array values, we can use into the program. And the third one is a runtime array. So for this, the value will be loaded at the time of execution, or we can say when the program is running. So let's see all this in detail. So the first one is compile time array. So in compile time array, the as discussed, the values will be loaded before the execution of the program. That means whenever you are writing a code or you are compiling the source code. So when the object is created, so that time the value will be loaded to the array. So there are some keywords which we used in declaration part. So the first one is dim, which represents the size of the array, means the number of elements but which array can hold. The second one is CT data, which represents the array will be of compile time array type. And the third keyword is per record, which represents the number of entries in one array records. And the declaration where we will be having the values of the array. So it will be all the array elements will be after the last statement of the program. So for further, we can see the sample program. So if you see the sample program, I have just declared an array name array1 of character 10. And the declare in keyword section, I have just declared the dim, which will be the size of the array. So that means it will be having 7 values in it. Then the second one is CT data that represents that this array is of compile time array. And the third one is per record. So that represents the number of values or number of entries in one record will be only one. But there is one limitation with a compile time array. If you see, whenever we need to modify or change any array values, then we need to recompile the program. Why? Because if you see the sample program, at the last statement, we have written asterisk CT data and the array name. So in below that we have written all the values of the array. So whenever you want to modify any record, or you want to add or manipulate any of the array element, that time you need to change the source code, which means you need to recompile the program. So that is the limitation of this compile time array. So let's see, the second one is pre-runtime array. So as I have told you, we are going to use some file, an external file in which we will be keeping all the values of the array, so that whenever you need to modify or you need to change the program, you don't need to recompile again and again. So that whenever you are using the values or adding or modifying any value, you don't need to recompile the program. But in that means we need to declare that file which is having all the values. And in declaration part, while you are declaring the file, you need to make sure like you are using T in file designation entry, and you are writing the record length. The record length, what it will be per record multiply with the size of one array element. Then the third keyword will be we are using will be from file instead of CT data, because CT data we have used for compile time, and for pre-run time we will be using from file and the file name. So let's see the sample program. If you see, this is a physical file pre-run app. In this, I have put all the values of the array, the 7 values of the array. And in program, you can see I have declared a file with T as a file designation entry, and the record length is 10. And while declaring the array, you can see array 1, I have declared of 10 character, and the size will be same as 7. And from file keyword I have used, and I have just written the file name, which we are going to use for the pre-runtime array, and per record 1. So this is a sample program. We will see in detail in green screen also. And the third one is runtime array. So runtime array means the value will be loaded at the time of execution, means at the time of running, when the program is running. And in declaration part, if you see, the declaration is very simple. You just need to declare the array 1 with a character 10. And in keyword, you just need to write dim, which represents the size of the array. So this is a simple declaration. So let's see all this array in green screen. So first one is we have read about compile time array. So this is a compile time array. If you see, I have declared an array 1 of character 10, which is having size 7. And the CT data means it is a compile time array, and the per record entry will be 1. If you see the declaration value, I need to press shift F7. Then while declaring, we need to write asterisk CT data, then the array 1. Then we are having all the values, 7 values there. And in program, I'm just reading all the values by using for loop from 1 to 7, because the size I have taken as 7, and incrementing by 1. So I'm just displaying array with an array 1 and the index value whenever it is just a loop. So that means array 1, array 2, array 3, I'm just populating or displaying on the screen. So let's see the output of the screen. I'm just compiling it so that it loads the value. I'm calling this. So you can see Sunday, Monday, all the values which I have declared at the bottom, I am just displaying it. If you see the second example, it is similar to that one, which we have already seen. But in this, if you see, I have declared array 1 of 10 character, and the size I have increased 7 to 14. And the city data is similar. It is a compile time array. And per record means I'm having 2 entries in the array in a record. If you see, I have just used a for loop, but what what is different? So we can see in declaration part, or while declaring the values, city data, asterisk city data, and the array 1. So if you see, I have declared we have an array of 10 characters. So after 10 position, I have just declared the another index value. If you see, that means this is an array index 1, array index 2, 3, 4. This is the meaning of per record 2. So means in one record, I'm having 2 values. If I want to change, then you can see I can change, but I need to recompile the program. So let's compile the program and let's see the output. If you see, the first one we have array index 1 is having Sunday, array index 2 is having 101 ABC, and else it is similar. You can see just the change is only in declaration part. I have declared per record 2. That means in one record I will be having true entries of the array. Then we have read about pre-runtime array. So first let me show you the DDS of physical file I have used. So this is the file which I have used for array table. So you can see the record name is pre-run R, and I have only declared one field which is of day, and the character length is 10 character. If I show you the output, so this is the output. That means it is all the values which we are going to use in an array or in a program, pre-runtime program. Let's see the program. So this is the program. If you see the declaration part, I have just declared a file pre-run f, and in file designation I have used t, and the record length I have just written as 10, because if you see the record length is 10, and else it is the same. And if you see while declaring the array, I have just declared the keyword dim7. That means the size of the array will be 7. And the from file, that means we are using an array table file named as pre-run f, and the per record having one value. So that is a program. And if you see in program, I have just initialized, declare a local variable increment having size 2 numeric, and initializing it with 1, so that I can just use a for loop from 1 to 7 and increment by 1. I'm just displaying the array index value. If I compile this program and call this, you can. Let's see what is. Yes, it's done. Okay, the file is opened. I think there is some error with this program, so I will check it. And so in runtime array, if you see, I've just declared an array 1 of character 10. The size of array will be 7. And the increment value, local variable I have declared of size 2 and initializing with 1. So if you see in for loop, I'm just incrementing by 1, and whatever the value of index or whatever the value of increment we are having, I'm just putting into the same as similar to that into an array value, and I'm just displaying all the values. Okay. If you see, I'm just displaying 1, 2, 3, whatever the index value or the increment value, I'm just populating to the array index. And if you see the runtime also, pre-runtime also, I haven't added the file name, so that's why it is giving an error. So if you see, I'm just showing all the values which we have in the file. Okay. So let's see, move further on PPT one. So let's see the built-in function or the opcode which we can use in array. So the first opcode we can use is sort A, which is used to sort the array elements. Means if you want to arrange it in ascending order or descending order, you can use sort A. And we have %lookup built-in function, and this is an opcode also, so you can use any one. So for percent lookup, it is just used to look for an element in the array. Means if you are looking or you want to search any element into the array, you can use percent lookup. Then the next one is percent xfoot, which is used to sum of all the array elements which is in array. Then percent lem, which will returns the value number of elements we are specified in the array. Then we have percent list, which returns a temporary array whose values of the item listed in the operand. Then the next one is percent split. So it is split a string into an array of substring, which all the values are declared in a string, and we will split into the substring. Then we have percent max array and min array. So as it defines, it will give an index value of the maximum or minimum in the array. Then we have subarray, percent subarray, which returns a section of the specified array from the starting index we want. So let's see all this in detail one. First is percent lookup. So as I have told you, it is used to look for an element in the array. So the syntax is not much big. So just I'm using percent lookup. Then the argument which we want to look for in the array. Then the array name. And the other two parameters is an optional parameter, the start index and the number of elements. This is an optional parameter. If you want to look for an element from a specified position, then you can use the start index or the number of elements you want to search for. If you see the sample program, I'm just using array one, a compile time array with a per entry record as one. If you see, I'm just returning an index value in an increment local variable feet, which is initialized with 0. If I look, if I've used percent lookup and then I'm just looking for 104 in the array 1, so what it will returns me? It will returns me the position of the index, or we can see the return. It will returns the index value. So if we found, then we are displaying the index value. You can see the second I have used with an optional parameter, like the increment. I'm just getting the value index value. Percent lookup 104 in array 1. The starting position will be I'm looking for 104 from first position to the fourth position. Okay, this is the simple use of the percent lookup. The next one is short a opcode, which is used to sort the array elements into ascending or descending order. For ascending order, in free format, I just need to use short a, the array name. And for descending order, I just need to use short a. In parentheses, we need to write D for descending order, then the array name. If you see, I have just I have declared a compile time array. So I'm just using short a, which will be given output in ascending order, and using a for loop displaying all the values of the array. Then after that, after arranging it in ascending order, I'm just making it to the descending order by using short a, and in parenthesis, I'm using D as an descending order and the array name. So it will give me an output in descending order. Let's see the next. Next, I will be using percent xfoot, which is used to sum up the array element. So the syntax is, you can see percent xfoot and then the array name. If you see the sample program, I am just using a runtime array and the local variable sum of length 5, which will returns the sum of all the values into this. Then you can see I'm assigning all the index value 1. For index 1, I'm having 10, 2 for 20, 3 has having 30, 4 is having 40, and the fifth one is having 10. I'm just getting an output into some variable which we have declared in the program with the length of 5. If I'm using percent xfoot and the array name, it will return me the sum of all the array elements. So means 10, 20, 30, 60, then 100 and 110. So it will return me an output as 110. Let's see the next one. Next is percent %lem, which is used to get the number of elements which we have specified in the array. And the syntax is simple, percent %lem, then the array name. If you see the same program, I have just used a runtime array, specified some length, some values to the array. Then in count, I'm just getting a number of elements we have which we have specified for the array, and then the percent %lem, then the array name. So it will returns me then 20 because the array size is 20. So then we have percent list. If you see in percent list, it will just return a temporary array whose elements have the values of the item listed in this operands. If you see the syntax, I have just written percent list, and in parentheses I am having the array one value, then colon sign, then the second value, and then colon, then the third value. So it will just give me an index one is item one, index two is item, and then index three is item. If you see the percent split also, the similar, the only change is in this percent split, I'm using a whole string. If you see split string into the substring, if you see the sample program, I'm just using a runtime array, two runtime array. I have declared array one and array two, having same character length 10. The size is also 7. If you see by using percent list, I have just declared the 5 values. Index 1 is red, index 2 is blue, index 3, array index 3 is pink, and array index 4 is black, and 5 is green. But it is separated by a colon. So when I'm just getting the values using this percent list, I will be getting the values 1, 2, 3, 4, 5 index value. And similarly, if you see the percent split, I'm just using, you can see I have declared a string in which a space separated by a space. So that means after a space, it is the next value of the array. So first value of the index will be red, the second value will be blue, then the third value will be pink, and the fourth value will be black, and then the green. Let's see the next. So let's see all this in green screen also. If you see, first we have learned about percent lookup. If I show, you can see I have just declared an array one, a compile time array, which will be having 5 value. If I show you the values also, the values are 101, 104, 102, 104, 103. So in this program, we are just using declaring a local variable increment, which will be receiving the value of the index and initializing with 0. You can see I have just used increment equal to percent lookup, and I'm looking for 104 in the array 1, and I'm just displaying the array position, the index value. Then with using the optional parameter, you can see I'm just initializing it with 0. Then I'm just looking, using the percent lookup, I'm looking for 104 in the array 1 from element 1 to the start index from 1st position to the 4th position. You can see. Then I'm just decrementing whenever it is found, then we are displaying it, and whenever it is not found, then we are using not found. So let's see the output. If you see, we have found array index 104 at 2, found at index 2. Okay, so it will return me the second value. If I want to change the value, if I change it, like if I will be looking for 3, 103 from first position to the fourth, so we have found at fourth position and at the second position. So first we are looking for percent 104, and it is returning fourth position because at first position it is not found, or second position previously it is giving, because we are having two values, so it will return the first value, the first index value. Okay, we have seen percent %lem. So what it will be, just I am declaring an runtime array and the local variable which will be getting the count, how many elements we have in the array. And you can see I have just initialized some array index value 10, 20, 30, 40, 10. And I'm just returning a value from percent by using percent %lem array 1. It will return the value in count and just displaying that output. If you see the output, you can see number of elements in array is 20. You can see in declaration also, I have just used the size as 20. Okay. Then we have some other built-in function like percent list we have learned about. So in this case, I have declared 3 array for 3 built-in function to show you. All are of character 10 and the size is also same 7. If you see in percent list, as told you, by you can see an operand between them. So by separating it by colon, and I'm just giving all the values. If I want to give some other values, I can just modify it by taking option 2. I'm modifying it. Add 1, add 2. So you can see I have used percent list, and what I'm just displaying list output. The array first in array 1, I'm just displaying the value 3. Value 3 will be pink. It will return as pink. We have read about percent subarray also, which will be just if you want to use some section of the array, so it will just return it from there. You can use percent array. If you see the second array, I'm just getting the values from first array from position 2 to 3 elements I am getting into array 2. Only 3 item, but it is in this array 1, I will be having 4. I'm just want 3 values, so I'm using percent array. The section of this first array will be moved to the first one. And when we use percent split, if you see in split, I'm just using in parentheses, I'm using red, blue in a string. If I want to display, it will just give me an index 1 value as red, index 2 value as blue, 3 as pink, and I am displaying here in the second value. If I want to display fourth value, I can just change it. Let's see the output. If you see for the percent list, I have just displayed the third value, it is pink. And for sub array, I have just moved 3 values. So you can see blue, pink, and black. And for percent split output, we can see we have displayed second, then it is returning as black. You can see the output. So array 3 is pink, and I will just use 3 values. So it is returning as 1, 3, blue, pink, and black for the sub array part. And for the display, the third array, fourth index will be black. So we are getting the correct output. Let's see the percent max and percent minim. So in this case also, I have declared an array of size 7 having numeric length of 10. So you can see the other two variables, local variables, I have declared max index and minimum index. So that just to store the index value into this local variable. I have assigned some values to index. You can see the array index 1 is 102. Oh, index 2 is having 109. Then index 3, 104. So by using percent max array, we can just get a return value, means maximum value will be 109. So that means we will be getting an array index is 2. In second case, when we use minimum percent minimum array, min array, so it will returns the minimum. So what we have the minimum at first position. So the output, I'm just displaying both the index value. If you see, we will be getting an output as 2 and 1 for the minimum. You can see for maximum, as told you, we will be getting 2, and for minimum, we will be getting 7. Let's see at 7. Okay, it is 100, so we are getting the correct output. So then we have read about sort A. If you see, I have just used declare an array, compile time array of size 5. Let's see the size, the values of the array. If you see 105, 101, 105, 102, 104, and 103. So what I am doing, I'm just at the first statement, you can see I'm just using short A and the array one, the name of the array. Then I'm just using for loop. And you can see I'm just using %lem, which we have already read, which will be from 1 to fifth, it will be reading from first to fifth position, and by incrementing by 1, and I'm just displaying the array value. And after that, once it is arranged in ascending order, then I'm just using short A in parenthesis D, which is for descending order, and the array name. So I'm just displaying the values. So if I compile this, you can see 101, 102, 103, 104, 105. These all 5 values from ascending by using short A. Then we have used short A in parenthesis D. That means it will be arranged in descending order. So I have just arranged it in descending order. So we are getting the correct output. And the next, we have read about %x foot, which will be used to sum of, it will return the sum of all the array elements. So I have just used a runtime array, array one. I'm just assigning some values, 10, 20 as discussed, as I've shown you. The output, it will give me as 110 by using %x foot array one. In this case, if you want to change some values, let's change some values, make it is 20, then now the output will be 120. So let's see the output. So 120, we are getting the correct output. So let's move further on the data structure part. So a data structure is a storage area where in the program that has multiple subfields and which can be of different data types also. So the basic use of this array data structure will be to break the field into subfields, or to group the fields, or to change the format of the field, and to convert the data from one to another. Now see, let's the types of data structure we have. We have several types of data structure. First one is program described data structure, which will be defined within the program. Then we will read about external described data structure. The data structure will be created based on the external file and which is referenced in the program. So we will be creating a data structure based on external file. Then we will read about multiple occurrence data structure. In this, it is allowed the same data structure to be used multiple times. And after that, we will be reading about array data structure, which is similar to the multi-occurrence data structure, but in this we will be using the index value. Then we will go with indicator data structure, which is used to rename the indicator in the program. Then we have data area data structure, which is used to define subfield based on the data area values. Then we have program status data structure. As you can see, the name describes, it contains the information about the program status. Then finally, we will read about file information data structure, which contains the information about file which is used in the program. So let's see this in detail. The first we have read about seen program described data structure. So this is defined within the program. As you can see the sample program I have used, I'm just declaring a data structure named as full name. It is having two subfields, first name and last name. Both are having of character length 10. And I'm just assigning some values to it. First name is having Virag and the last name is having Sharma. I'm just displaying the full name instead of both this individual name. So it will return me an output as Virag Sharma in a single line. So this is an example of subfield. To group the field, now see, this is an example to break fields into subfields. If you see, I have just declared a data structure $timestamp of character 50. Then I'm just declaring some subfields, 5 subfields, current date, current year, month, day, and hour. But I'm assigning some values to it from some position to it, from position 1 to 8. The in data structure timestamp, it will be considered as current date. From position 1 to 4, it will be considered as year. 5th to 6th will be month, and the 7th to 8th will be the day, and from 9th to 10 will be the hour, and you can use other timestamp value also. So in this case, I'm just assigning a values to the data structure, which will be, you can see the automatically it will assign values to the subfields which we have declared from position 1 to the end position, and the start position we have already declared. So we will see this example in green screen also. Let's see the other. The other keyword is qualified. You can see the qualified basically specify the subfields of the data structure which will be accessed or which can be used by using the data structure name followed by a period and the subfield name. If you see, I have just declared a data structure name, full name, and I have just qualified it. And it is having a two subfield, first name and last name. So if you see an example, I'm just using the data structure name, then the subfield name separated by a period, and then I'm assigning some values. So this is the use of the qualified data structure. The most important use whenever you are having similar fields in the program, then you can use qualified. So it will just differentiate by because it will be using the data structure name in front of it. Then we have other keyword is like DS. So which is used to create a data structure which is already declared in the program, or you can see which will be having a subfield similar to the parent data structure by using the parameter DS, like DS in the declaration part. You can see I have just having a one data structure name as class 1, which is qualified. That means class 1 dot first name we need to use. And the second, I'm using a data structure class 2 by using like DS. As similar, I'm just creating a data structure based on class 1. I'm just for accessing one, you can see for class first data structure will be used as class 1 dot first name, and the second data structure it is also get qualified because we have used in first parent data structure, so it will be class 2 dot first name, so it will be giving the value. Now the next data structure we have read about external data structure, external described data structure, which is which will create data structure based on the external file and which is referenced in the program. So it is useful for maintaining consistency across multiple program. And the important keyword is you can see the ext name we have used with file name. In declaration part, we just need to use the declare the data structure name. And in keyword section, the ext name, which means we are creating a data structure based on some external file. You can see pre-run F. So we will see in green screen also. And the next, we will be having multi-occurrence data structure in which it will allow the same data structure to be used multiple times, and it is to use to handle repetitive data. And the important keyword we have used is occur. You can see in the declaration part also, and we have some subfields from position 1 to 5 and 6 to 10. Then we will be having array data structure. If you see, we are creating a data structure and with qualifying it, and I'm using a dim. Dim 10 means it is an array. And I'm declaring two subfields name, which is having 25 length, and then num underscore children will be having 10 character, 10 numeric. So whenever I'm just creating a data structure, so you can see I'm just assigning a values family. Family is a data structure name. Index 1 will be having a name of Sanjay, and the index 1, the second subfield will be having 2. Similarly, we can use the array index 2. So it is very useful for us. And then the next one we are having is indicator data structure. As I have told you, it is just used to rename the indicator which are used in the program, so that it will just make us some meaningful name we can assign to it, so that it will easy to remember why this indicator is used for. And the important keyword which is INDARA, which is used in the display file. You can see this is a screenshot of display file. I have used INDRA indicator, which means will be using indicator data structure, and I have just declared two indicator 0, 3, and 12 indicator in the display file. In program, if you see the declaration part, I have just declared the display file. And in display file in keyword section, I have used INDDS, which represent I'm using some indicator data structure, and the name of data structure will be INDDS1. I can just give any name to it. And for function key 03, I will be using, instead of 03, I will be using exit in the program. And for function key 12, I will be using cancel in the program. So let's see the next one. Next, will be having area data structure. So the basic use of this area data structure is whenever you want to use, or it can be used in different programs or jobs. It is very useful for sharing data. If you see, I'm just keeping the values in a data area. I've created DTA01, in which I will be having a string declare 20 character, and this will be containing Virag Sharma as a name. And in declaration part, if you see, I have just declared a data structure. U means it is a data area data structure, DS is data structure. And in keyword section, you can see I have just used DTA ARA, which means it is a data area. And the name is DTA01 I have used. And I have just used subfields will be first name and last name. From position, it will automatically take. So first position to fifth position, it will take as first name. And from position 7 to 20, it will consider as last name. And the second last, we will be having file information data structure. So it will give the information about the file which is used in the program. If you see, this is already defined by the IBMI. You just whatever you want to use from this, you can just use it from position by defining the position. In declaration part, while declaring the physical file, you just need to declare in keyword section INFDS and the data structure name. So this is information data structure and the name is file info. I have declared a file info and the position is already defined by IBMI. We just need to use the position. If you are want to get the file name, then position 1 to 8. If your program is ended or not, the indicator value and the file, it will return from position 10. The record length will be, you will be getting from position 38 to 45 and the else other. Next, see the last one. Last, we will be having program status data structure. So it will give you the information about the program status, like the last operation you have performed, the error message, if there is any error message. This is also defined by IBMI. You just need to declare the data structure name, like I have declared PGM. And in declaration, you can see instead of U or something, we have used S, which means it is a program status data structure. For this also, the position is already defined by the IBMI. You can see the position. If you want to process a name, then from position 1 to 10, you can use. If you want the number of subroutines, name of the RPG routines, then you can use 29 to 36. Then if you want to know the parameters used, you can use position 37 to 39. So let's see all this in green screen. So first we have program described data structure. So let's see an example. If you see, I have just declared a data structure full name and the subfield is having first name, last name. Both are of character 10. If I'm just initializing some values to the subfield and instead of displaying individual, I can just use the full name just to group it. So if we want to see the output, I'm just compiling it and can just call it. You can see in one line, we are getting the output. So to break the field into subfields, if you see, I'm just declaring a data structure. The declaration type is data structure and the length will be 50. And the name will be $timestamp I'm using. The second subfield, the first subfield we are declaring is current date, which will be from position 1 to 8. The second value will be subfield will be current year from position 1 to 4. Similarly, the month and from similarly the day and the hour from 9 to 10 position I am just declaring. After that, I'm just using percent timestamp to get the timestamp value into an data structure and just displaying all the subfields. You can see I'm not initializing it, but it will automatically take from position. It will take the value. So let's see all the values. So you can see this is the timestamp value. If you see the current date is from position 1 to 8. So we are getting 2810. Then from position 1 to 4, we will be having year. 5 to 6 is month. 7 to 8 is day. Then hour. The next one is qualified data structure we have used. I have used a similar data structure, full name data structure. I'm just qualifying the data structure. So when we are qualified the data structure, that means we need to use the data structure name and the value. So if you see, I can just value change the value of it. You can just display the Arnav Sharma. Okay, I'm first using the display, the full data structure name, then the last name I'm just displaying. Okay. Then we have read about the keyword like DS. If you see, I have declared a data structure class 1, which is qualified. That means we need to use class 1 dot first name as a field if we want to use the subfield. And I have declared another data structure similar to that one, class 2, which is will be having the subfield similar to the parents one. That means class 1. If you see class 1 first name, I'm using Virag, and the class 2 means that has second data structure. I'm just assigning the value Sanjay, and both will be displaying. I'm displaying it. If you see the output, you can see I have declared first for class 1, first name is Virag, and for class 2, the first name is Sanjay. Then we have read about external data structure. If you see, I'm using a data structure. I have defined a data structure pre-run f based on file pf02. If you see the DDS of second file, so this is the DDS first name and last name. So it will automatically create a data structure which will be having a subfield of first name having 10 character and the last name is 10 character. If you see the output, and let me show you this in debug so that it will give a more clarity. So you can see the data structure value. You can see first name and the last name is automatically defined into the data structure. So this is the use of external name data structure, external defined data structure, we can say. Then we have indicator data structure, which is used to rename the indicator value. For this, you can see the display file I have created, and I have just declared indicator data structure name INDDS1, while in keyword, I have just declared written INDDS, which is for information data structure. So let's see the DDS of display file first. So this is the display file I have used. You can see the in keyword section, I have just written INDRA, which means I will be using indicator data structure. And I'm using two indicators, CS03 and CS12, which will be function key 03 and function key 12. I will be using the program. In program, you can see I just declare the display file, with the INDS keyword. And while declaring the data structure, you can see I have just used renaming 03 to exit. I'm just declaring INDA, that means it is an indicator for 03. And for 12, I will be using cancel. After that, I'm just do while loop until it will run when this is off. When it gets on, 03 gets on, that means we will need to leave the loop. And I'm just ex empty will just display the file. So you will read about ex15 upcoming section also. I'm just compiling it and displaying. It is in debug mode. So you can see the screen I have displayed. I can use F3 and just come out of the program. Then we have array data structure. I have declared a data structure name as families, which is qualified, and the array size will be 10. So I can use family 1, family index with having index 1, family index 2, in which I will be having two subfields, name and number of children. Num children means I'm just declaring a local variable of 10. And I'm just assigning some values. You can see how we can going to assign values to it. If you see, I just use family 1, index 1, name and num underscore children values. Then we are using family 2. I am assigning values to it. And I'm just displaying family 1, the name. If you want, I can just display the second value also, the family 2 name. You can see the first name is Sanjay, the second name we have declared is name. So the second example, I am just showing you, I can just use the same program. Instead of that, I'm just initializing one more subarray. You can see children subarray I have used, declare here of size 3, so that I can just declare one more subfield name, the children name and the age. If you see the declaration, how we are going to use that part. So you can see the family 1, we have already seen. This part we have already seen in first example. So this children, the second array which we have declared in the array data structure, you can see how we are going to use the family 1. Then the sub array is children 1 and the name of the child. You can see this is the process to use the subfield of the array. And then the second family 2, if you want to assign some values to the children, child 1, it will be having child 2. Further, I'm just displaying all the values to the screen. So this is the use of sub array data structure. You can see this is a sub array and this is an array data structure we have already declared. I'm just compiling it and calling it. So I'm just displaying family 1 is family 1. I have just given assigned some name family 1. Child is also having child 1. You can see the age is 12 and this is the output we will get. Then we have data area data structure. So let me show you the output of, not the output, the value what we have in this data area. So to look for a data, to create a data area, we can use CRT, DTA, ARA. Then you can create an array, a data area by using this command. So I'm just displaying the data values which we have already defined in DTA01. DTA01. So I have already declared from position 1 to 5 is Virag and from position to 7 to 20 is Sharma. So this is the part. You can see I'm just declare a data structure dsgta underscore dta, and declaration part you can just use u. That means it is a data area and the declaration type is data structure. And in keyword section, you need to use GTA ARA, but that means it is a data area data structure, data area you are using, and the name of that data area will be DTA01. And there are some fields we have declare first name will be from first position to fifth position of this data area, and this last name will be having 7 to 20 position of this data area. And to retrieving the value, we need to use in with the data area name. And once it is fetched, then you just need to use out so that it will be out of that data area. So let's see the output. You can see the correct output we are getting. Then we are having program status data structure. You can see I have already told you all the values are defined by IBMI. You just need to use that values which are defined. You can see I have used the program PGM, or you can see I can just rename it program status data structure. This is a declaration S with a DS as a data structure name, and all the position are defined by IBMI. Proc1 is means procedure name you want to get. Then if you the most importantly use is job name, which is from position 244 to 253. The job user you can see from 254 to 263. The job number will be from 264 to 260. These are the importantly used. You can see the start date, program date, time, compile time. When we have compiled this object, you can get all the information by using program status data structure. In this part, I'm just displaying the job name, job user, and the job number, which is commonly used. I'm just compiling it, just displaying the value. You can see QP8 dev 001 is a job. The username is team PIO, and you can see the job number is 589803. So I think we have covered all the topics regarding array and data structure. So we are good. So if you are having any doubt, then you can ask.
Everyone, if anyone have a question, so you can mention in the chat Q&A box so that Vira can answer. Okay, one question over there.
For compile time, if we update data in physical files, need to compile our program. In that case, it will be a pre-runtime array. It is not a compile time array if you are using declaring a values in separate physical file.
And queries related to case study, we will notify you the Skype group. So anyone have related questions to the array and DS, so you can put in the Q&A box.
So one question is any specific difference between pre-runtime and compile time array? So if you see in compile time array, we are declaring all the values at the last statement of the source code. And in pre-runtime, we are using an external file just to avoid the decompilation of the source code. So that is the main difference in the compile time array and pre-runtime array. And the next one we are having program status and file information data structure, how we can know the field. So it is already declared and the position is already defined by IBMI. You just need to declare the data structure, whatever the values you want, you can just declare the position of that field that what the field you want to use.
Any more questions? Yeah, Virag, there one more question they asking about like if we want to see all the fields of DS, so how we can do?
You can just display all the values, whatever values you want to use. You can just define the position of that in the data structure, and you can use it.
I hope you got all the you got all the answers. Okay, there one more question. Okay, so I think there were no more questions. So we are good to wrap up this session. Thank you, everyone.
Thank you, everyone.